over here at the sideboard on geometry on Thursday, the 15th of this fine month of October. We're halfway through October, guys. SWVA students will be able to solve statements about angles, section 2.8, okay? So just like how we had all these proofs about segments in this last section, now we're going to do proofs about angles. And I know you guys struggled through those proofs about segments, and I appreciate you guys doing that, okay? We're going to continue doing it with proofs about angles. And what I'm hoping will happen today, okay, is things will start to click a little bit more as we are continuing to practice more and more proofs, okay? That's really what it takes. It just takes continual practice and time and effort, okay? So we're going to talk about proofs with angles. We have all these properties of equality that we had before. The addition, subtraction, multiplication, division, properties of equality, properties of congruence. So we have our transitive, reflexive, symmetric, all of those. Okay, we've seen those before, right? We've been using those. Then we have these different definitions. So, definition of congruence. Well, we've seen definition of congruence with segments, right? Okay, it just said, hey, if two things have equal measure, now they're congruent. This one's saying the same thing, but with angles. If two angles have equal measure, the angles are congruent. And the arrow goes both directions because it goes both directions like a biconditional does. Back from section 4, okay? I believe. Section 3. So measure of angle A is equal to measure of angle B. Well, then the angles are congruent, or vice versa. Definition of angle bisector. Hey guys, you remember real quick before we do this? You remember how I said words to math or math to words probably a definition? You guys remember that? Okay, that's where this is really going to come in handy when we have all these definitions. Okay. Definition of angle bisector. What's an angle bisector do? Do you guys remember that back from chapter 1? An angle bisector. What's the word bi, or what's the prefix bi mean? Two. And sector kind of looks like sections. So it cuts it into two sections, two equal sections. So an angle bisector divides an angle into two equal parts. Could you kind of use this word to help you remember what it does? Okay? I'm trying to give you guys tools like that and a way to think, okay, to where you can have these words and you can see them, and it's going to be able to help you. Okay? Instead of having to try and remember all of these different things, you have different tools and resources to remember them. Okay? So, definition of angle bisector: bisecting two sections of an angle, cuts it into two sections that are equal. Cuts it in half. Okay? Definition of complementary angles. What's it mean for two angles to be complementary? Nope, that'd be congruent.
They equal 90.
They add up to equal 90. Hey, you guys remember my complementary angles poster over there that I love? Okay, Kevin, you want to read that poster for me? What's angle B saying to angle A?
I like that you're a good friend.
And what's angle A saying to angle B?
I like the way you always help me.
Get it, guys? They're complementing each other because they're complementary angles because they add up to 90, okay? So definition of complementary angles: if they're complementary, their sum is 90. If their sum is 90, they're complementary. It goes both directions. Definition of supplementary angles. Supplementary means they add up to what? 180. Same idea, but they're adding up to a bigger number. Supplement, complement. Are those words pretty similar? So if we can remember which one's which, if we remember complement is 90, then you can remember supplement is 180, okay? Or vice versa. If two angles are supplementary, their sum is 180. They add up to 180. Definition of perpendicular. What's it mean for two things to be perpendicular? Okay, that's not just parallel.
That's different.
Hey, what?
They're the same.
Nope.
Oh, they both cross.
They cross how? A special way.
X.
Cross.
Special way. Okay, they make right angles, don't they? Okay, they make four right angles. So perpendicular lines form right angles. So this definition is just what it means. That's what definition is. It's what it means, okay? So if two lines are perpendicular, they're forming right angles. Definition of a right angle. Well, how much does a right angle equal? 90 degrees. That's their definition. If it's a right angle, it's 90 degrees. If it's 90 degrees, it's a right angle. Definition. Continuing on. We have these postulates. Did we have the segment addition postulate? Okay, that meant you add two small segments, you get a big segment. Angle addition postulate. You add two small angles, you get the big angle. Does that sound familiar? We did it back in chapter 1. If you add two small angles, you get the big angle. Okay? Enjoying yourself, Tyler? Okay. Vertical angles theorem. If two angles are vertical, then they are congruent. Do you remember what kind of what angles are vertical angles? What that means? Okay, not 180. Nope, that's linear pair, I think. Nope, not necessarily.
Vertical, straight up and down.
Vertical angles are the ones that make an X. They're opposite each other. So like those two that I just marked in the orange, those are vertical angles. They are opposite each other, and their sides make the X. Okay? Vertical angles are always, always, always congruent. Vertical angles theorem. Angles are vertical, then they're congruent. It has the word in the explanation, doesn't it? Vertical angles theorem. Angles are vertical. Okay. Complement theorem. Okay, so it's probably gonna have the word complement in there somewhere, right? If two angles form a right angle, then they're complementary. Well, if two angles form a right angle, how much is a right angle? 90 degrees. So if they form a right angle together, they have to add up to what? 90. So then they're complementary. So if two angles form a right angle together, then they're complementary. That's what the complement theorem is saying. Supplement theorem, if two angles form a linear pair add up to what? 180. So if they form a linear pair, then they have to add up to 180, so then they're supplementary. It's kind of like you're skipping the middle step in both of these. So this is the supplement theorem. If they are a linear pair, then they're supplementary. Congruent complements theorem. Congruent complements theorem. If angle A is complementary to angle B, and angle C is complementary to angle B, then angle A is then angle A is congruent to angle C. Okay, what's complementary mean again? It means it adds up to what? 90. Okay, so angle A is complementary to angle B. So somebody give me a measure for angle A. Let's go with Quentin. Give me a measure for angle A less than 90. 50. So if measure of angle A is 50 degrees, and we're told that angle A is complementary to angle B. So what's our angle B have to measure? 40. Very good. Now we're also told angle C is complementary to angle B. So if angle B is 40 degrees, what's angle C have to be? 50. So what do we notice about angles A and angle C? They're equal in measure. So if they're equal in measure, they are congruent, and that's what it says. Then these are congruent. Is there any other option for them to be congruent if they're both complementary to angle B?
40.
No. Well, so unless angle B changes, the other two angles won't change. So if two angles are complementary to the same angle, they're congruent. Here's the way we can remember this. How many times do we see the word complementary here? Twice. Is complements here plural, singular? Plural. Plural means how many times? Multiple, two or more. Do we see complementary two or more times? Yes. So complements, we see complementary twice. Kind of a hint. Okay? And it deals with angles being congruent in the end. You see complements, you have congruent angles. Congruent supplements theorem. What do you think is going to change between congruent complements theorem and congruent supplements theorem? They're going to add up to 180 instead. If angle A is supplementary to angle B, and angle C is supplementary to angle B, then angle A is congruent to angle C. Do we still see supplements twice? Yeah, and so we have supplements. Supplements twice, congruent angles. Okay? And to the explanation of this one, if I wanted to add together some angles, somebody give me a measure of angle A. Christian, go ahead and give me a measure of angle A. Yep, give me a measure of angle A. It could be any angle. Less than 180.
90.
Okay, 90. So if angle A is 90 degrees, what does measure of angle B have to be to add up to 180 with it? 90 degrees. So we're told angle A and angle B are supplementary, which is now true. We're also told angle C is supplementary to angle B. So if angle B is 90 degrees, what's angle C have to be? 90 as well. And in this case, all three are congruent. But that's a special scenario because 90 was half of that 180.
Unless you have 45.
Okay, unless you have the 45 for the other one, okay? So if you had maybe like, 70 and 110, well then angle C has to be 70 again to be complementary with angle B. Or supplementary with angle B, excuse me. So now angle A and angle C are congruent. Questions on any of these? Okay, we're going to practice some of these. Just by using each of these, using a theorem or postulate. So these take practice, right? Practice, 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 practice. Well, guess what? We're practicing. If angle A is a right angle, then measure of angle A equals 90 degrees. Here's my hint for you guys. We start with words. If angle A is a right angle, we end with math. Measure of angle A equals 90 degrees. Words to math or math to words is a big hint we're doing what?
Definition.
A definition. To figure out what definition, it is correct that we're doing a definition. That's a big hint. Definition of, okay. Well, what words are we seeing here? Right angle. Is definition of right angle one of ours?
Yes.
So if angle A is a right angle, the measure of angle A equals 90 degrees. Is that what it means to be a right angle? Yeah. So this is definition of right angle.
Can we just put a right angle?
Nope, you can write out right and then put the word and then put the symbol for angle if you want. Great question though. Question on that first one.
Oh,
Yes.
why can't you put definition complementary?
Great question. So why wouldn't it be complementary, Ray?
No complementary.
Because it doesn't mention not supplementary, complementary.
Yeah. So complementary. If angles are complementary, you have to have two angles adding up. And this is just one angle. Okay. That's a good question. Number 2. If angle X is supplementary to angle Y, and angle X is supplementary to angle Z, then angle Y is congruent to angle Z. Well, we're seeing a word a lot here, aren't we? What word are we seeing a lot here, guys? This could be a hint for us. Supplementary. How many times do we see it, actually? Twice. Wait, where do we see it? Where do we see supplements twice? Supplementary twice. Nope. Supplement theorem means if two angles are supplementary, that they form a linear pair. Which one of those was plural? Congruent supplements theorem. Hey, angle X is supplementary to this angle. Angle X is supplementary to another angle. Now those angles are congruent. So you have supplements and you have congruent supplements theorem. Does that make sense?
Yeah.
You had supplements and you have congruent angles. So congruent supplements theorem
Where is that? Oh.
is the very last one we covered. Okay. Hey guys, on that previous page, it might be helpful for you guys to write in little notes, by the way. Even if I don't tell you these, if I say something, you're like, oh, that's a good way to remember it. And maybe you're like, maybe I should make a note that this is plural. And I see supplementary twice, okay? Maybe I should do that. Good luck. Okay? You guys can do those notes without me telling you to write it down, okay? I want you guys to have these notes be helpful for you. So if that's something that would be helpful for you, I want you to write that down. So if I say something in class and you're like, oh, that made a lot of sense, but you didn't write it down. Well, you can write it down, okay? Continuing on. If we have this diagram for angle 1 and angle 2, then angle 1 is congruent to angle 2. What kind of angles are those in the diagram? Not necessarily. They're vertical. They're opposite each other and they make an X. That's what we know. And so if the two angles are vertical, they're congruent. That is the vertical angles theorem. So if we can recognize that they are vertical angles, that can help us out with the fact that it's the vertical angles theorem. Right, Bailey? Okay. Number 4. If measure of angle measure of angle P and measure of angle Q equals 90 degrees, then angle P and angle Q are complementary. Well, we went from math, we had an equation, two things added together and equaling a number, to a bunch of words. Math to words is a big hint for what? A definition. Math to words, words to math, big hint for definition. Ray, what are you thinking? Not of congruence. Definition of congruence would say if two things have equal measure, they're now congruent, or the other way around. Definition of what words do we see popping up? Complementary. Definition of complementary angles. Very good. Definition of complementary angles. If two angles add up to 90, they're complementary. If they're complementary, they add up to 90.
Wait, why can't we put the other one?
Definition of congruence.
Yeah.
Are the angles equal in measure?
Oh, wait. Oh, no. Nope.
Okay.
It's adding.
Yep. Number 5. If angle M and angle N form a right angle, then angle M and angle N are complementary. Great question. Are we going from words to math or math to words?
The same.
Okay, it's words to words, so it's probably not a definition. Okay? And another way we can tell they're a little bit different is this says 90 degrees, they add it to 90. This says they form a right angle. Those are slightly different, even though we kind of know that and they end up meaning the same thing, right? Okay? Chase, what are you thinking? It is the complement theorem. The complement theorem says, hey, if two angles form a right angle, they're complementary. Or the other way around, if they're complementary, they form a right angle. Questions on that? Continuing on.
Thank you.
Given all of this diagram with line L, line M, and angle 1. If if line L is perpendicular to line M, then angle 1 is a right angle. So we're given this math. Might not look like math, but we're given this math. Line L is perpendicular to line M. That's math. Then words, angle 1 is a right angle. So we're going math to words. So what's that probably a hint for? Definition. Okay, what words do we see? Okay, and actually this one's a little bit tricky. So it's not definition of right angle, unfortunately. It's definition of... Nope. Chase? Definition of perpendicular. That's what perpendicular means. If two lines are perpendicular, they form right angles. We said that earlier, right? We said, hey, when I asked, what's perpendicular mean? And he said, they intersect. And I said, how? And he said, they form right angles. I'm like, oh, yeah, that's what it means. Seth?
Upside down, can we put it sideways?
No, but good question.
Or
No, it'd be just a normal T, though. If angle W and angle X are supplementary, then their measures add to 180. Did we go from words to math? Presley saying yes. Presley, what's that probably mean? It's probably a definition. So we narrowed it down a bit. Now, for definition, we like to see what words are involved. Seth?
Supplementary.
Definition of supplementary angles, because we see the word that they are supplementary. If two angles are supplementary, they add to 180. If they add to 180, they're supplementary. Either way. No, sup, period, angles. Number 8, ornate. If angle L is complementary to angle M, and angle N is complementary to angle M, then angle L is congruent to angle N. Well, we're not going words to math or math to words. It's not a definition. Okay, we're not dealing with things being equal and then congruent. Sorry, we're not dealing with things being equal and congruent, so it's not definition of congruence either. Seth, what are you thinking?
Congruent complement theorem.
Yeah, congruent complements theorem. And Seth, what was a kind of a giveaway that helped you to get to that point?
It said complementary twice.
It said complementary twice. So complementary twice, so that means it's plural. And so that's complements. And then we end up with them being congruent. So it's the congruent complements theorem. On number 9, if angle A and angle B form a linear pair, then angle A and angle B are supplementary. Does this look like a definition to us?
No.
No, it's not words to math or math to words, it's words to words. Okay, what'd you say? It looks like a theorem. Okay, which theorem might it look like to us?
Supplement.
Okay, Ray, what are you thinking? I would agree it's a supplement theorem. If two angles form a linear pair, then they're supplementary. That's our supplement theorem. Now, do we still see the word supplement show up in supplement theorem? Yeah, we still do, that they are supplementary. Number 10. If angle N and angle P are complementary, then their measures add up to 90. What's this kind of look like to us, guys?
Definition theorem.
A definition. Why do you say definition, Seth? I agree with you.
It's from word to math and math to word.
It's from words to math. Okay, so if you're going words to math or math to words, probably a definition. Now, what words do we see here? Definition of complementary angles. If these two angles are complementary, they add up to 90. That's what it means to be complementary. We talked about that in chapter 1 just a bit ago, even though those angles are complementing each other on my poster and being nice.
I thought A would be like, I'm the best.
That's not complimenting someone else, though.
And then B would be like, yeah.
Oh, okay. Okay, on number 11, we have this diagram with these angles, and we're told, okay, measure of angle JKM plus measure of angle MKL is equal to measure of angle JKL. Ray?
Angle addition.
Oh, you nailed it. We're adding up the two smaller angles to get the whole big angle. Angle addition postulate. Angle add post. So kind of like we had seg add post for segment addition postulate. Angle addition postulate. You're adding two small segments to get the big segment. Or, excuse me, two small angles to get the big angle. What's that?
The first topic is adding angles now.
Sorry, say that one more time.
So the post office is now adding angles.
Yes, the post. I get you. All right, number 12. If measure of angle R is equal to measure of angle S, then those angles are congruent, right? Nailed it, definition of congruence. Now, Mr. Costle, this one's not words to math or math to words. Why is it a definition? Definition of congruence is our one exception to that rule. Okay, definition of congruence is our exception to that rule. But it'll always follow this format or the reverse, the converse of it, I should say. So if their measures are equal, they're congruent, or vice versa. Okay, good luck. Okay, continuing on. Okay, so we have the segment, we have the angle proof reference here, a guide here, a little word bank, property bank. Okay, and we're going, yep, it did. And then we're going to we're going to use these. So on number 1, I put the word bank with it on the paper so that way we don't have to keep flipping the page if you don't want. Okay, yes, Seth? Yes, why don't you move right behind Christian or right next to Quentin for now, okay? Thanks for asking, buddy. No, I appreciate you advocating for yourself. So here, number 1. Okay, Elizabeth. Yes, good luck. Okay, yes. That is given. Our first reason is always given, that it's a right angle. Now, I'm a huge advocate of marking information on a picture. Is there any way we can mark the fact that angle PQR is a right angle?
Yep.
How do we mark that on a picture?
It literally says given.
But how do we show that on a picture that something's a right angle?
Square.
The little box, right? The little square. Okay? That can be helpful. I'm a huge advocate, huge supporter of marking that off. Okay? Of marking on our picture all the time.
Can I just rip this page out and staple it back in?
If you want. Okay? I think you showed me. Yeah, okay, that works. So now we went from it is a right angle to it's equal to 90 degrees. Is this words to math?
No.
What are we thinking, guys?
Definition
Definition.
of right angle.
In this case, of a right angle, because we see the words right angle in there. And what's it mean for something to be a right angle, guys? It's 90 degrees. And so that's what we see happening. What does it mean? What's the definition? Have you guys ever heard those used it pretty interchangeably in real life? Okay, what's something mean versus can you define that for me? Okay. On number 3, measure of angle PQS plus measure of angle SQR is equal to measure of angle PQR. What's that kind of look like we're doing there?
Math.
Okay, we're doing math to math, so it's not anything like a definition.
Theorem.
Okay, or a theorem. We're doing addition. What are we adding?
Measure PQS to measure SQR.
Okay, and what are those? Those are what kind of things we're adding? They are complementary, but we have to get there at the end. They are angles. We're adding angles. We're adding two small angles to get a big angle. So it's the angle addition postulate. Ray, is that what you're going to say?
Yeah.
Awesome. It is the angle addition postulate. Now on number 4, we said, okay, well, measure of angle PQR is equal to 90 degrees. And measuring angle PQR is also equal to the sum of these two angles in step 3. So now the sum of those angles is equal to 90 degrees. Okay, Ray, what are you thinking?
Is it supplement theorem?
It's not actually. It's one of them in our word bank though, but it's not supplement theorem. So we don't have supplements either. So it's not going to be a supplement theorem. Okay, Seth?
Transitive.
That is our transitive property, okay? Transitive property. It's where you have kind of the link. You have like 3 sets of equal signs. Okay? Hey guys, here's a way that you can kind of help see transitive property sometimes. It's not always going to happen this way, but it's something to look for. When you see equal sign, equal sign, equal sign like that, and you notice, oh, I see the same thing show up twice. It's probably it's going to be transitive property, and we follow through here. Well, this over here in the blue is equal to both the green and the purple. So the blue is equal to both the green and the purple. So the purple is probably equal to the green. That's transitive property, okay? Maybe break it down into colors. So now we went from these two things had to be 90 degrees, and so they have to be complementary. Did we go math to words?
Yes.
We did. So what's this probably going to be? Definition. In this case, definition complementary, because that's the word we see. It's also the last thing we have in our word bank, isn't it? Definition of complementary angles. So it's on the back of the other page, and I also put it on this slide for us. Yeah. But to try and make it easier so you don't have to flip all the time, I did try to put it up here if you guys can read it. Any questions on number 1 here? Are we feeling like these are making a little more sense than they were the other day?
Yeah.
Okay. That's why I was saying, guys. It takes practice and practice and practice. And after a while, you start noticing patterns. You start getting better at this line of thinking. You start getting better at the step-by-step process. You really do.
Yeah, angles are easier.
Okay. Okay. Do you think angles are easier than segments with Haswell in general? Do you think we should start with angles?
Yeah.
I wonder if I should try and reverse them next year. Okay.
I always thought that the angles were it's just a little bit more straightforward.
All right.
People would understand.
Well, and I'm wondering if the angles are just easier because it's the second thing we do. So if we flip them, segments would be easier, or if angles are just actually easier. Because I'd be curious to try it. All right. Angle 2 is equal to angle 3. What's our reasoning for that on number 2? Given. Now, is there a way I can mark that on my picture? No, I don't have a way to mark that 2 things are congruent. Can you want to tell me how I mark the angles are congruent on the picture?
They have the dots in between.
No,
Two lines.
the arcs. The lines are for segments. The arcs are for angles. Now, do we have another given somewhere in here? Yeah, it's number 3, isn't it? Right? Okay. Now, a lot of times I think it's helpful for us to put that in there right away. Because otherwise we can forget about it, okay? So I think it can be very helpful to go ahead and put that in there right away. Because otherwise we can get caught up and we say, how did I get to number 3? How did I get to number 3? How did I get to number 3? And we overlook the fact that it was just given to us. And we start pulling our hair out looking for a reason. But the only reason is that it's given to us. So if we notice right away that there's 2 things that are given, but we only see 1 in the first step, there's going to be 1 later on. So find it and go ahead and mark given so that way you have it out of the way. Now, step 1 and step 2, we're probably going to use what we just had. So we went from these 2 things being congruent to now their measures are equal. What is that says if they're congruent, their measures are equal? Seth? Definition of congruence. Every time, if we see the same things pop up from one step to the other, and the only thing that changed instead of equal signs we see congruence, it's going to be definition of congruence every time. So step 3 was our other given. That angle 1 and angle 2 form a linear pair. So now we're saying, okay, well, angle 1 and angle 2 are supplementary. If they form a linear pair, they're supplementary. What here can tell us that if they form a linear pair, they're supplementary? Supplement theorem. If we start looking through our word bank, that actually is the one that makes the most sense because it can't be a definition. It's not going word to math, math to word. So this is the supplement theorem saying, hey, if two things are supplementary, or excuse me, two things form a linear pair, they have to be supplementary. From angle 4 to angle 5, or number 4 to number 5, I said angle. Number 4 to number 5, angle 1 and 2 are supplementary. Now they add up to 180. If two things are supplementary, now they're out of 180. Transitive is when you see like those three equal signs in a row. It is going to be definition of supplementary angles. We see words to math. Okay? So that's always going to be definition of supplementary angles. That's what it means for two things to be supplementary, is they add up to 180. Now on number 6, measure of angle 1 and the measure of angle 3 equals 180. Well, are we going math to math? Or are we doing math to words at all? Or words to math? No, it's probably not a definition. Okay, Seth, what are you thinking? Substitution. Seth, what are you substituting here on the step by chance?
Measure 2 and measure 3.
Where do we see that those things are equal? Back in step 2, we're told that the measure of angle 2 is equal for the measure of angle 3. So it's perfectly okay for us to go up here and say, hey, from 5 to 6, I can swap out the measure of angle 2 for the measure of angle 3. It's perfectly okay for us to do that because we were told that their measures were equal right away. So we can change them out and leave everything else the same. So if you notice that you see something and it looks almost identical to an earlier equation, and only one thing's changed, go back and see if you're told anywhere that those two things that were changed out for each other are equal. If so, it's going to be substitution, okay? So 2 changed to 3. Oh, they're equal to each other. We're substituting them. So now we go from word or math to words. These two add up to 180. Now they're supplementary. What tells us we can do that?
Definition of supplementary.
Definition of supplementary. If they add up to 180, they are supplementary.
Angles.
I also think, Mr. Koppel, that it helps a lot when you have a word that's
Yeah. Especially a word being specific to the problem. Yeah. By the way, on our test, we will have a property bank.
Thank you.
Okay? It won't be specific to the problem, but we will have a property bank. Okay? So the list of any possible properties you could use will be on there. So you don't have to remember all of the names. You just have to know what the names mean when you read them. Okay? That's why I'm teaching you how to read them and know what they mean. So I'm teaching you all these patterns. Okay? Is because you just have to be able to read them to know. Okay? We're going to skip number 3. We're going to try number 4. Number 4, we're given that the ray BE bisects angle ABD. We're also given that ray BD bisects angle EBC. Does anyone want to help me out on any of these steps right now? Besides Seth, who's been helping out a ton, which I appreciate. Okay? Ray. First one's a given, isn't it? Okay? Oh, nice. The third one's a given too. I like it, Ray. You're following my advice from earlier. Put in all the givens right away. Okay, that's going to be helpful for us. Okay? So everyone make sure you have this down. Okay, everyone make sure you have it done. You have it done? Dope. You're ahead of me, my bad. Okay? From number 1, number 2, we're told that ray BE, this ray right here, bisects this angle ABD. Now we're told that angle ABE and angle EBD are congruent. Is that what a bisector does? Cuts it in half. Okay? And do we go from what to what? We go from math or words to math. So it is the definition of angle bisector. That's what an angle bisector means. If it's what something means, that's the definition. Just like in real life, if I'm saying, hey, what's that mean? I'm defining it. Number 3 and number 4, because we already have number 3 as our given. What do we think is happening? Words to math. And are we seeing basically the same exact thing that happened from 1 to 2 as happening 3 to 4? Just with different angles? Okay, so what's it going to be? Definition of angle bisector. So now, I said earlier when you see 3 equal signs in a row, or see 3 equal signs throughout it. Now we don't see 3 equal signs, but instead we see 3 what? Congruent symbols. Congruent, congruent, congruent. And are we seeing each of these things twice? Angle ABE, we see that twice. Angle EBD, we see that twice. And angle DBC, we see that twice. So we see all of these twice, and we're saying, okay, if we go up to our picture and mark that these angles are congruent, angle ABD is congruent to angle EBD. Angle EBD, which we already has one arc on, is congruent to angle DBC. Can we see in our picture that angle ABE should be congruent to angle DBC? Yeah, and so it's the fact that because that they're both congruent to our middle angle here. So what property is that? Transitive property.
I forgot, I don't know if this will make it more confusing for them, but I was taught that EBD repeats, so you have ABE and then EBD, and then EBD does two repeat, and then it just goes from ABE to whatever that DBC is. I was taught that when those two repeat themselves,
Mm-hmm.
that makes it transitive as well.
So like when the EBD repeats itself?
Yeah.
Okay, so Ms. Haswell's saying, hey, when we see this kind of equaling or being congruent to something, repeating, and then it kind of disappears, that's probably a hint that there's transitive, okay? So if we see it repeating, and then we see it kind of disappear, that's probably a hint that there's transitive, okay? That might be helpful for some of us to look at, okay? A lot of this is pattern recognition and a process of how to think. Okay, we are going to skip number 5. Okay, and we're going to do number 6. Okay, angle 1 and angle 2 are complementary. Angle 3 and angle 4 are complementary. Ryan, what's one of the things we can fill in right now?
Given.
Okay, number 1 is a given. What's our other given? Number 2. Now in number 3, we have measure of angle 1 and measure of angle 2 equal 90 degrees. Do we see words that might support this earlier? Where do we see that? Step 1 or step 2?
I mean, step 2. 1,
Why is it 1 and not 2?
because 2 is angle 3 and 4.
Because 2 is talking about different angles. So we went from step 1 to step 3, kind of. These are complementary. Now they add up to 90 degrees. What can we do to get that? Not right angle, but definition of complementary angles. If 2 angles are complement, they add up to 90 degrees. The next one would be the exact same thing. Very good, Tony. If angle 3 and 4 are complementary, now they add up to 90. We're basically doing the same thing over, just with different angles.
It's basically a repeat of everything.
Now we're saying angle 2 is congruent to angle 3. Now this actually doesn't follow any of these first 4. If we try and figure out what it follows, we'll notice that we won't find anything to actually go off of. So if we get to this point where we're looking above, what is this going off of? How do we get here? We get stuck. Look at the picture. Angles 2 and angles 3. What kind of angles are those? They are acute. What other kind of angles are they? They're congruent, but it says that. How do we know they're congruent, though? What kind of angles are those? Do the sides make an X? The sides do make an X there. So they're vertical angles. And vertical angles are always congruent because of our vertical angles theorem. Yeah.
I don't know, I'm like, not confused, but I was wondering if it goes from words to math problem, that would be definition.
Yeah, where do we see that?
No, I was just asking.
Okay. Yep. Yep, words to math and math to words, definition. Yep, good thing to write down. All right, on number 5 to number 6. Do we see the kind of the same thing in 5 as in 6?
Yeah.
But what changed?
They're equal to now.
Definition of congruent.
They're equal instead of congruent. So it's definition of congruence.
Why wouldn't 6 be vertical?
Great question. Why wouldn't 6 be vertical like 5 was? So vertical angles theorem says that if 2 angles are vertical, they're congruent. It doesn't say their measures are equal. It's true that their measures are equal, but the theorem itself says they're congruent. So we have to take one more step and say, what's congruent mean? Well, it means their measures are equal. So you just have to take that one extra step. It's like you're explaining this to like someone who's 5 years old. But if you're explaining something to someone who's 5, you have to give a lot more detail, don't you? Because they're going to miss some things that you would just maybe assume. Okay? And so it's kind of like that. So we have to give every single step. Does that make more sense, Kevin?
Yeah.
Great question. Number 7, measure angle 1 plus measure angle 2 equals measure angle 3 plus measure angle 4. We have this big equation. Well, Ms. Haswell gave this tip earlier. If we see something is equal to another thing twice, and then it disappears, that might be a hint. Okay? Ray, what are you thinking?
Wouldn't it be complement theorem?
No, what Tony said earlier, though.
What is this then?
Yeah,
Oh, it's the transitive.
the transitive property. Going clear back to steps 3 and 4. So sometimes we kind of skip some steps and then go back to it. It's kind of weird, okay?
Wouldn't it be the complement theorem?
So the complement theorem is saying if two angles are complementary, they add up to 90. Or excuse me, if two angles are complementary, they form a right angle. That's what the complement theorem says. If they form a right angle, they're complementary.
Well, if, like, angle 3 and angle 4 are both added together, wouldn't that be one angle then?
You could call it another angle like angle 5, but we don't have a name for that angle right now. But what we see here is we see in steps 3 and 4, measure of angle 1, measure of angle 2, and measure of angle 3 and measure of angle 4 both equal 90. Then all of a sudden 90 kind of disappears. But we see measure of angle 1 and measure of angle 2 again. We see measure of angle 3 and measure of angle 4 again. So if they're both equal to 90, does that mean they're equal to each other? And yeah, and that was our transitive property like Tony said. Now in step 7 to step 8, we see almost the same exact equation, don't we? But what changed?
Measures of
2's gone, it became what?
3.
3. Were we told those two things are equal earlier? Yeah. So can we substitute them?
How's there 2, 3?
There are 2 3's now. We substituted the 2 for the 3, and we kept the other 3 there. So the thing we substituted was measure angle 2 is equal to the measure angle 3, which we know to be the case from step 6. Now from number 8 to number 9, we got rid of some stuff, didn't we? It's like it trimmed down. What's gone on the left-hand side of that equation?
3
Measure of angle 3. What's gone on the right-hand side?
and 3.
The measure of angle 3. So measure of angle 3 is gone from both sides. It was being added on both sides. Now it's gone. How do we get rid of something being added to both sides? Subtract. So if I subtracted by the measure of angle 3 on both sides, would that get rid of it? Yeah, so it's a subtraction property of equality, telling us, hey, we can subtract the same thing from both sides of an equation, and it's A-okay. So now we go from, on number 9, number 10, do we have basically the same thing in 9 as in 10?
Yep.
But what changed?
Just the M was taken away.
M was taken away. Instead of equal, it's congruent. So someone besides Seth, what is it when we have two things that are the same, and now that instead of being equal, they're congruent? Oh, crap. What?
Congruent complement.
Not quite. That'd be multiple complements. We use it earlier in this problem to go the other direction. Elizabeth. Definition of congruence. If two things have equal measures, they're congruent. We use it earlier in the problem to say, hey, if two things are congruent, they have equal measure. Question on number 6. Okay. We're going to skip 7. We're going to skip 8. And we're going to do 9 together.
Skip those 2.
On number 9. What's our first reason? Given.
But
Yes, good luck. Do we have another given later on, guys?
Yes.
Where is it at?
It's at 7.
It's at 7, so can we write that in as a freebie? Yeah, angle 2 and angle 3 or complementary? So we filled in a couple freebies already, right? Kind of handy. So we went from number 1 to number 2. We went from math to words. Math to words. I know this might not look like math to us, but it is math to words. Segment AB is perpendicular to segment BC, and now we saw angle ABC is a right angle. Definition of, well, now we think it might be right angle because that's the word we see. We see the word right angle, so we think, oh, definition of right angle. But that's used on the next one. So this is probably different. Okay, Chase. Definition of perpendicular. If two things are perpendicular, they form a right angle. And we can mark in our picture that angle ABC is a right angle. In fact, I'm going to. Definition of perpendicular. It's an upside down T. It means perpendicular. They kind of look like a mini perpendicular lines. Now, I said from 2 to 3, my reasoning is definition of right angle. So if I have words in number 2, what am I going to probably have in number 3 then? Probably math if I'm using a definition. What's it mean for something to be a right angle?
ABC equals 90.
That the measure of angle ABC is equal to 90 degrees. For it to be a right angle means it equals 90 degrees. Now, measure of angle 1 plus measure of angle 3 equals measure of angle ABC. Do I see anything earlier in steps 1, 2, 3 that might get me to that? No. So let's look at the picture. Angle 1 plus angle 2 is measure of angle ABC. What's happening with those? They're getting added. Are two small angles being added to get a big angle? Yes. So what's that? The angle addition postulate. Okay. Now, do we see 3 equal signs in a row again? Yes, we do. And like Mrs. Haswell noted earlier, we see measure of angle ABC, we see measure of angle ABC, and then it kind of disappears. Do we notice that it was equal to the two things that are equal to each other now?
Mm-hmm.
Okay, so what property might that be?
Transitive.
Transitive property. Very good. Now from 5 to 6, it said my reasoning was that it was a definition of complementary angles. So if I started out with math, what might I go to? Words. Landon, are you raising your hand or just holding your arm there? Okay. Okay. If I started out with math, it's probably going to go to words. So what might I say about angle 1 and angle 3? Angle 1 and angle 3 are what? What? Complementary. If they add to 90, does that mean they're complementary? If they add it to 90, does that mean they're complementary? Yeah. So the definition is. Now, if we notice in 6 and 7, we see something twice in a row. Angle 1 and angle 3 are complementary. Angle 2 and angle 3 are complementary. And now we see something angles being congruent. So we had a plural of complements, didn't we? We had a plural of complements, didn't we? So what did we talk about earlier when you have a plural of complements? Not quite. Complement theorem has one complement. Congruent complements theorem. If two angles complement to the same other angle, they're congruent to each other. Congruent complements theorem.